So, hi everyone, welcome back to our YouTube channel Moments with Chemistry. So today we are going to continue the series that we had already initiated. So today we have to start out with question number 11. Consider the following compounds. A, B, C, D, E are given. All these 5 compounds have the same relative molecular mass. Then they are asking the variation of boiling points. Okay. So now for boiling point, what are the factors that we should consider? The main governing factor is the strength of intermolecular attractions. So the one with the highest strength of intermolecular attractions will have the highest boiling point and vice versa. So here the highest intermolecular attraction will come with an alcohol. It will come with an alcohol. Why? Because alcohol has the OH group that can form hydrogen bonds. So the highest boiling point should be with E. Highest boiling point should be with E. Highest boiling point. Next one. After that, it should be a aldehyde. Why aldehyde? Because aldehydes can form dipole-dipole attractions. So dipole-dipole attractions are stronger than London forces, but they are weaker than hydrogen bonds. So here we have 2 aldehydes, both C and D. And the other thing is, when the number of side chains on the main carbon chain increases, like this. If this is the side chain and the number, if this is the main chain, and if the number of side chains increases, the effective surface area decreases. So if there's more and more side chains, the effective surface area decreases and thereby the London force strength also decreases. So therefore, if we have more and more R groups, the boiling point is less. So then C should be the next highest, no? C is the next highest, and then it will be D. Then if you consider A and B, both of them are simple alkanes. So since they are simple alkanes, they have only London forces as the predominant forces. But the boiling point of B is less. Why? We have more R groups. Lesser surface area. Lesser surface area means less amount of London forces. So if the number of London forces that come onto a molecule are less, then what will happen? Boiling point is also less. So then the next one will be A, and finally you will have B. So the correct graph that gives you such a variation is the second one. So for question number 11, your answer will be the second one. Okay, question number 12. Increasing order of covalent character of chemical species. Okay. Now for covalent character, what are the things that we have to consider to judge the covalent factor? What are the other characteristics that we have to consider? You have to consider the polarizability of the anion and the polarizing power of the cation. If the polarizability of the anion is greater, covalent character is greater. And if the polarizing power of the cation is lesser, then what will happen? Your covalent character will also be lesser. So first of all, we will just consider a pair that has the same anion or same cation. For example, you consider NaCl and KCl. For both of them, the size and charge of the anion is common, Cl minus. The charge of the cation is the same, +1. But K plus is bigger than Na plus. So since K plus is bigger than Na plus, the polarizing power of K plus is lesser than Na plus, which means that the ionic character of KCl is greater. So if the ionic character of KCl is greater, then the covalent character of KCl is lesser. So if we are to compare the covalent character of NaCl is bigger than the covalent character of KCl. That is one conclusion that we can come up to. So now this is one thing which I have got to. So only from this, first one is out. Throw it to the dustbin. First one is out. Second one possible. Third one also possible. Second one is also possible. Third one is also possible. Fourth one is out. Fifth one is out. So between 2 and 3 only now we have to fight. Now the battle is between only second one and the third answer. Okay. Now look at the next 2 species. KF and KCl. Now I'm going to consider KF and KCl. You can take anything. So if you consider KF and KCl, charge and size of the cation K plus is common. Okay, charge on the anion is common, -1. But the size of Cl minus is bigger. So since the size of Cl minus is bigger, the polarizability of Cl minus is bigger, which means the covalent character that is associated with KCl, the covalent character that is associated with KCl is greater than that of KCF. Okay, covalent character of KCl is greater than the covalent character of KF. So the only answer that satisfies both these conditions is the third one. So your answer for question number 12 is the third one. So your answer for question number 12 is the third one. Okay. Now we come for the next question. Question number 13. Standard combustion enthalpies of H2 gas, carbon solid and CH3OH liquid are given. Numerical values for combustion enthalpies are given. Enthalpy of vaporization of CH3OH liquid is also given. Question is asking what is the enthalpy of formation of 1 mole of gaseous CH3OH. Okay, this question has a lot of mathematical calculation that you have to do. We'll go one by one slowly. So, considering only the combustion enthalpies, H2 gas, O2 gas giving you H2O liquid. So to form only 1 mole of H2 gas should react. So this, the enthalpy change that is associated with this is given as minus 286 kilojoule per mole. Next one is for carbon, carbon solid plus oxygen gas giving you carbon dioxide gas. Carbon dioxide gas. This value is given as minus 393 kilojoule per mole. Next one is CH3OH liquid, OH liquid and oxygen. What are the products? Mere carbon dioxide and water. H2O liquid, very important, carbon dioxide gas. So one carbon okay. Hydrogen 4. So this should be 2. So here total amount of oxygen is here 2 plus 2, 4 oxygen. But here we have 1. So remaining how much? 4 minus 1 is 3. So 3 oxygen should come from this. So that will be 3 by 2. Then the enthalpy change associated with this is minus 726 kilojoule per mole. Enthalpy of vaporization of CH3OH liquid. Then CH3OH liquid to CH3OH gas, CH3OH liquid to CH3OH gas is given as 37 kilojoule per mole. 37 kilojoule per mole. Okay. What is the question asking? Question is asking you to find the enthalpy of formation of 1 mole of gaseous CH3OH. So we have to form CH3OH gas 1 mole. So you have to have carbon solid graphite plus H2 gas plus O2 gas. So to form one of this we need half. Here 4, then this is 2. 1 carbon, okay. Now if I consider this to be X, we are supposed to find X. Okay, so this I am taking as equation number 1, this one 2, this one 3, this one 4. Now I have to find the value for X, which means CH3OH gas should come to the right side. So if CH3OH gas should come to the right side, what should happen? Fourth equation should be directly added here. Fourth equation will be directly added here. Plus, this third equation should be flipped. Only if this equation is flipped, this CH3OH and this CH3OH will get cut. Plus, minus the third equation. Then what will happen? If I just flip up the third equation, just look at this. 2H2O plus carbon dioxide in this side. 3/2 oxygen in this side. Okay. We need 1 carbon. Jolly well, we also have 1 carbon. Plus 2. Okay. First one. Now look at the first equation. Look at the first equation. Fourth one is okay. Third one is okay. Second one is okay. Now I have to deal out with the first equation. First equation, I multiply the equation by 2 because I need here 2H2 no. So if I multiply this equation by 2, I will get the 2H2 here. No problem. I'll get the 2H2O here. Then here I'll get just one oxygen and 2H2O liquid. This 2H2O liquid, this 2H2O liquid will get cancelled. This carbon dioxide and this carbon dioxide will get cancelled. Okay. This carbon dioxide will get cancelled. Plus, here we have 3/2 oxygen, 1.5 oxygen. But here we have 1 oxygen. Only this one, no? 1 oxygen. So, this side, when you flip the third equation to your right side, you are coming out with 3/2 oxygen. You are coming up with 3/2 oxygen. Plus, this side what do we have? 1 oxygen, 1 oxygen, 2 oxygen. This side we have 2 oxygen in the left side. In the right side you have 1.5 oxygen. So if you take it to the other side, you will end up with half oxygen. So jolly well we have that also. So it should be plus first equation into 2. If you do this one, fourth equation, what is the value? 37 plus. Third equation minus 726. So that is plus 726 plus the second equation minus 393 plus the first equation minus 286 into 2. If you solve this, you will come up with 202 kilojoule per mole. So that is the second answer. For question number 13, your answer will be the third answer, minus 202 kilojoule per mole. You just write 4 equations and just think. Now here I have to get 1 carbon, what should I do? I have to get 2 hydrogen, what should I do? I have to get half oxygen, what should I do? Here I have to get CH3OH gas, what should I do? It's just like playing chess, no? You know all the pieces, you just have to put it together. Just try to fit into a puzzle, that's it. Okay? So there you get minus 202. Okay, question number 14. Phosphorus can be prepared in an electric furnace as given by the following balanced chemical equation. 2 calcium phosphate plus 6 silicon dioxide plus 10 carbon giving you 6 calcium silicate, 10 carbon monoxide and P4. This is a given equation, we don't have to even bother. Good thing that they have even balanced the equation and given. Ca3 PO4 twice plus 6 silicon dioxide plus 10 carbon giving you 6 calcium silicate plus 10 carbon monoxide plus P4. Then 620 grams of calcium phosphate, 180 grams of silicon dioxide, 96 grams of carbon were reacted, 50 grams of P4 were obtained. Under these conditions, the limiting reagent and the percentage yield of P4 respectively are. Okay. First we'll find the number of moles of Ca3PO4 twice. That is equal to 620 divided by molar mass. Molar mass of this one is 310. So 620 divided by 310 is 2 moles. Silicon dioxide. Number of moles of silicon dioxide, that is equal to 180 divided by here 32 plus silicon is 28, 60. That is how much? 3 moles. Then number of moles of carbon, 96 divided by 12. 96 divided by 12. If you divide this, you will get roughly 6. You will get roughly 6, no? Here into 6, 12, 100. No. Then you have to, I think, go with 8 moles. 8 moles. Now we have to find the limiting factor. Okay. If I consider calcium phosphate to be the limiting factor, 2 what should be the number of moles of silicon dioxide that react? 2 by 2 into 6. That is 6 moles now. Do I have 6 moles of silicon dioxide? No. So, calcium phosphate cannot be the limiting factor. First answer is out. First answer out. If I consider silicon dioxide to be the limiting factor, 3 divided by 6 into 2 to find the number of moles of calcium phosphate. So this is 1 mole. Calcium phosphate, jolly well, he has 2 moles. He can give 1 mole. There's no problem in that. Okay. So therefore, silicon dioxide is my limiting factor. Limiting factor silicon dioxide. So third answer is also out. Fifth answer is also out. So your answer should be either 2 or 4. Okay. Then they are asking us percentage yield. Okay, now silicon dioxide is limiting factor. So number of moles of P4 equal to formed 3 divided by 6 into 1. That is half moles. Okay. 3 divided by 6 into 1. So then the mass of P4 obtained is 0.5 into 4 into P31. 0.5 into 4 is how much? Half of 4 is 2. 2 into 31 is 62. 62 grams. So percentage yield equal to what we obtained 50 divided by what we are supposed to obtain through theory. Through theory we have to obtain 62 grams. But we have only obtained 50. So this will give you the percentage yield if you multiply by 100. So now don't waste your time going to solve this. For God's sake, don't waste your time going to solve this. Now see, 50 over 62. Now if it should be, let's say, 50% yield. For example, 50% yield means 32, no? 32. But this is greater than 50. So your yield should be greater than 50. So the only possible answer is the second one. Third one is out because that is 40 point something. So for question number 14, your answer will be answer number 2. Okay? This is how you do it. Okay, question number 15. Consider the two equilibria occurring in two separate rigid closed containers under the same conditions. Same conditions is very important. Pressure is same or any other factor that affects the Kp, Kc is same in this particular scenario. Okay, then N2 and 3H2 giving you 2NH3, Kp1 given, Kp2 given. Under these conditions, what is the Kp for that particular equilibrium? Okay. I'll write Kp1 expression without just going to put the factors. I'll just put Kp1 expression. Kp1 expression is NH3 gas concentration squared divided by H2 gas to the power 3 into N2 gas. Kp2 equal to NH4HS gas divided by H2S gas into NH3 gas. Kp, what we have supposed to find, NH4HS gas squared divided by H2S gas into NH3 gas. Okay, now just look. On top we have to get NH4HS squared now. So instead of Kp I can write Kp2 squared. Okay. H2S will come down. H2S squared now. If I just multiply it by this particular value, if I just multiply it, just think, I had to get NH4HS gas squared over H2S into NH3. Okay, H2S should come down. Jolly well it has come down. H2S squared down. Okay, Kp2 squared. So NH4HS squared divided by H2S squared into NH3 squared. This entire squared portion will come here. Plus, down, can you see I had to get NH3? I had to get NH3 down. So if I divide it by Kp1, I divide it by Kp1. So then what will happen? Look at this. Instead of Kp2 I can write NH4HS squared divided by H2S squared into NH3 squared. Kp1 I can write. For Kp1 it should come down. No? For Kp1 it should be down. Okay, yeah, correct. NH4HS squared divided by H2S squared into NH3 squared. Now that one comes for this particular process when I substitute Kp2 squared. Okay, then I have to cancel, wait, 2H2S, N2 gas and 3H2. NH4H divided by H2S squared, I think that's not issue. H2S squared into NH3 gas, H2S squared into N2 gas into H2 gas cube. So since H2 gas cube should come down, since that should come down, I multiply this one by Kp1. I multiply Kp2 by Kp1. Okay. Now, if you do this multiplication, you will end up with this Kp value. Okay. Now just substituting values. Kp1 is 3 into 10 to the power 4 squared into Kp1 is 8 into 10 to the power minus 4. So this is 3 3s are, okay, this is 3 3s are 9. 3 into 3, 9. Wait, 3 into 10 to the power minus 4 into Kp2 squared, 8 into 10 to the power minus 4 squared into Kp1, 3 into 10 to the power minus 4. So here 8 8s are 64, 64 into 3 is 192. Okay, 64 into 3 is 192 into 10 to the power minus 12. So it should be 1.92 into 10 to the power minus 10. But unfortunately such an answer is not given. They have given you only 1.92 10 to the power minus 8. So after 15 all. For 15 the answer should be most probably all, because 10 to the power minus 10 now here we are getting. Okay, so that's 15th. 16th one. Consider the nitration reaction of bromobenzene. Resonance stabilized carbocation intermediates are formed during this reaction. True or no? Which of the following is not a resonance structure of these intermediates? Okay. So what are we doing? We are taking bromobenzene. And conc HNO3, conc H2SO4. So since this is an orthopara director, what will happen? Bromine. Either you will get NO2 here, or you can even get NO2 here. Okay. Now we have to find which is the wrong one. Now look at the first one. First one is possible no, because if you here we have H no H. So the NO2 plus electrophile will come. This is the first step, no? Or yeah, if I want to add it here. Then this is H and this is NO2. That is how the reaction will go. This is H, this is NO2. Both H and NO2 will cleavage the bond like this. So the first step is, now this is just bromine, don't even worry about it. NO2 plus okay, here bromine, this carbon will become plus, this will become H and NO2. So H and NO2 should be attached to the same carbon. First one is okay, second one is okay. Third one is wrong. No? This bond will never get cleaved. The cleavage happens only at the ortho or para position. This particular bond is not going to get cleaved. The BR bond won't get cleaved. So that's a very easy one. Question number 16, answer is answer number 3. Okay, question number 17. A reaction which is non-spontaneous at room temperature and 1 atm pressure becomes spontaneous at high temperatures at the same pressure. Which of the following is correct for this reaction at room temperature? Okay, at room temperature it's a non-spontaneous reaction. If the reaction is non-spontaneous, for sure delta G should be positive. Why? Non-spontaneous. So your answer should be either 1, 2, 3, 4 and 5, don't even think about it. Okay, and it becomes spontaneous at high temperature, which means if you increase the value for T by some means, delta G becomes negative. How can that happen? Now imagine like this, if you increase T, the T delta S value will become more and more negative. This portion becomes more negative. The T delta S value becomes more negative. So if you increase T and T delta S should be more negative, for sure your delta S value will be a positive value. And since delta S is a positive value, at a certain point, the negative portion of T delta S becomes so negative such that it suppresses the positive charge here, the positive value for delta H. Now imagine if delta H was negative here, then even at room temperature this should have been spontaneously. But that doesn't happen. Why? At room temperature, the T delta S portion is not sufficient to create a huge impact on delta G. So to satisfy all this condition, at room temperature delta G should be positive, delta H should be positive, and delta S should be also positive. Positive, positive, positive. And they also have told us that delta H and delta S do not change with temperature pressure, which means that they are temperature pressure independent. Whatever you do to the temperature and pressure, the value for delta H and delta S at room temperature is equal to the value at the new given conditions. So therefore your answer should be positive, positive, positive. For question number 17, your answer is answer number 1. Okay, question number 18. This question had been constructed using the knowledge in unit 1, using de Broglie's hypothesis. The de Broglie wavelength of a neutron traveling with velocity v is lambda. With velocity v is lambda. If the kinetic energy E, they have given the expression also, E equal to half mv squared. Of this neutron is increased 4 times, the new de Broglie wavelength should be. Okay, first we will recall the expression lambda equal to h over mv. That is de Broglie's hypothesis. And E equal to half mv squared. Half mv squared. Imagine I square both sides of this equation. Then E squared equal to 1 over 4 into m squared v squared. Okay, 1 over 4 m squared v squared. What is m squared v squared? Okay, now this is one way as to how I can approach. The other way as to how I am going to approach is I multiply this side by m and this side also by m. That is a more easier approach. I multiply this side by m and this side by m. Then here 2me equal to m squared v squared. So mv equal to 2me root. 2me root. So that is equal to h over, instead of mv I can substitute 2me root. Okay. Then they are telling in a new situation, the energy becomes 4 times. So if energy becomes 4 times, if you take 4 out of the root, this entire quantity will be multiplied by half. No? The new value will be half. So therefore your lambda dash is equal to lambda by 2. First answer. If you make E 4 times, that change causes a 2 decrement or half. The entire expression will be multiplied by half. If you multiply E by 4, the entire expression will be multiplied by half. Why? Because E is inside the root. So your answer for question number 18 is answer number 1, lambda by 2. Question number 19. Which of the following correctly shows an electrolytic cell constructed for the electrolysis of an aqueous solution of salt MX? Okay. So this is also very direct one from electrolysis. Okay. You know, in electrolysis, if I consider two rods that have been immersed in a solution of an electrolyte, the positive terminal is always connected to the anode and it should be positive. The negative terminal is always connected to the cathode. So from that, first one is wrong because the positive terminal has been connected to cathode. So that's wrong. Second one is correct. Third one, the naming is correct, but then the polarity is wrong. Anode should be positive. Why? It's connected to the positive terminal of the battery. Third one, although the naming is correct, the polarities are wrong. Fourth one, naming is itself wrong, so we don't have to think. Fifth one, anyways, for the positive one, they have gone and connected the cathode. That's also wrong. So your answer for question number 19 will be answer number 2. Question number 20. Which of the following statements is correct regarding the reaction between carboxylic acid and alcohol to give an ester? Carboxylic acid reacts with alcohol to give an ester. Okay. ROH and R-COOH gives you R-COOR, and you use conc H2SO4 as the catalyst. This is a type of nucleophilic substitution reaction. You know why it's substitution? It's nucleophilic because ROH has lone pairs that can be donated. So lone pair donated. So the lone pair donated. Why is it substitution? If you consider the carboxylic acid, RCO, this is how it is now. And this is OHR. Okay. This is OH. So here a water molecule should be eliminated like this. Water molecule is eliminated. So here instead of OH group on the carboxylic acid, a new R group comes and attaches. So therefore it's a type of a substitution reaction. So first one, the overall reaction is nucleophilic addition. Wrong. It is not a nucleophilic addition actually. It's a type of nucleophilic substitution. Second one, the reaction in which, it is a reaction in which alcohol acts as a nucleophile. Correct? No. Alcohol has ROH. A lone pair that can be donated is present in alcohol. So due to the presence of a lone pair, what is a nucleophile? It should be either a negative charge carrying organic species or inorganic species, or it should contain lone pairs for donation. It should donate anything that it has extra. So reaction in which alcohol acts as a nucleophile is correct due to the presence of lone pair. Second one is the answer. Third one, it is a reaction in which the cleavage of OH bond of the carboxylic acid. Actually it's not the OH bond, it's the CO bond that gets cleaved. Look at this. If you consider the reaction mechanism, OH, slight negative, slight positive. He comes like this, so he has to open up. Then R, CO, OH, R. This is positive. This is OH. This is negative. Then again he gives, he is out. Then we come up with R, C, O, R. He will also cleave. Okay. Which means there is a cleavage of only the CO carbonyl group. Although we show water molecule going out like that, there is a cleavage in the CO bond, not in the OH bond. So that's wrong. It is a reaction which occurs with the cleavage of the CO bond of the alcohol. Alcohol doesn't have CO bond, no. Alcohol, it just donates. There is no cleavage in the alcohol molecule. There is no cleavage in alcohol molecule. So therefore fourth one is wrong. Fifth one, acid-base reaction. No, it's not. If it should be an acid-base reaction, normally if you consider organic chemistry, we categorize them as acid-base reaction mainly if they release hydrogen or due to the involvement of an acidic hydrogen in the reaction. Here this reaction, no acidic hydrogen. There is a nucleophilic substitution only taking place. No acidic hydrogen at all. So fifth one is also wrong. So your answer for question number 20 is answer number 2. Okay. So this is the end of our second video, and in today's video we had discussed from question number 11 to question number 20. I hope this video would have amounted to something, and we hope to do our next videos which are already in the queue, so they will be uploaded within the next few days perhaps. So if you have any comments, any suggestions, please do include them down there in the comment box, and don't forget, like, share, subscribe. Thank you and have a nice day. Hey everyone, I think that particular video had added some amount of advantage to your pinnacle of success. Chemistry will indeed become one of your most favorite subjects at the end of what we take as a journey. So don't forget to like, share and subscribe this particular channel with those whom you like. And wait, whether your comments are advantageous or disadvantageous, please do put them down in the chat box, because everything amounts to us. So thank you and have a nice day.